Hello, thank you so much for watching. We are solving systems of equations by elimination this time, okay? All right, when you're solving systems of equations by elimination, it is also called linear combination. So I don't want you to be confused if you ever see linear combination as a word that you would see in your curriculum in OMS and also just in Google if you're looking at the elimination method. Both of them mean the same thing and they mean that you're doing the same thing. Okay, so first let's look at when you're solving some systems of equations through elimination or linear combination method, what you're doing is you're adding or subtracting the equations to eliminate one of those variables. And one of the things you may have to do is you may have to multiply by a factor first. Not always, but you might. On number two, we're going to solve the resulting equation by the remaining variables. And then step three, we're going to substitute the value that we found in step two. Say we found x, you're going to plug that back into the equation from step one and solve for that second variable. So let's see it in action. The first thing you want to do is analyze your variables. When you're trying to eliminate, you want to see which ones can I easily eliminate. Well, I have a negative 3x plus y equals negative 2, and I have a negative 2x minus y equals 3. So it's clear to me that these y's can be eliminated. I have a positive y here and a negative y there. So I'm going to rewrite these. And all I have to do is add, and I will combine my equations. That's why it's called linear combination as well. I'll combine my equations by adding, and I will see that those y's will eliminate. So we're going to simply just add here. And we're combining the equations together. So negative 3x minus 2y, that gives me a negative 5x. Y minus y, there's that elimination. So I don't have to worry about my y's here, equals a negative 2 plus 3, and that's going to give me 1. I solve my equation like usual, divide by negative 5 on each side, and I can see that x is a negative 1/5. From here, I'm going to take my x as my solution to this equation and put it back in one of these equations over here, either 1 or 2, either one is fine, and find my y coordinate now. So I'm just going to start with the very first equation, negative 3x plus y equals negative 2. I'm going to plug in my x, so I have a negative 3x minus 1/5 plus y equals a negative 2. And I'm simply going to solve. A negative 3 times a negative 1/5 is a positive 3/5 plus y equals a negative 2. I'm going to subtract 3/5 on each side here. It disappears from that side and I have y by itself. And what I notice is I have a negative 2 minus 3/5. Well, I want to change that 2 so that it's fifths. I want to change that negative 2 so that it's fifths. So I'm going to put a 5 in the denominator and a negative 10 in the numerator so that it still equals negative 2. And then write the rest of my problem here. Again, that negative 2 changed to a negative 10 fifths. If you divide negative 10 by 5, you do get a negative 2. So then as I add these two fractions, negative 10 fifths minus 3/5, that gives me a negative 13 fifths. And I'm going to leave it just like that. That is the solution to my equation. Y is a negative 13 fifths, x is a negative 1/5. So my solution is a negative 1/5, negative 13 fifths, and that is one solution. Now in this particular problem, I can see here as I analyze, I've got a negative 2x right here, and I've got a positive 2x. So again, it is easy to eliminate. I do not have to multiply by a factor because they're already ready to eliminate. So I'm going to rewrite this problem here to show you how we're going to eliminate. I've got a negative 2x plus y equals negative 13, and then I have 2x minus 3y equals a negative 9. So from here, all I have to do is add them. These eliminate. I'm left with y minus 3y. That's going to give me a negative 2y. A negative 13 minus 9 is going to give me a negative 22. From here, I'm going to divide by a negative 2 on both sides. And y equals a positive 11. From here, remember, I'm going to go back to any equation that you want. You can choose one or you can choose two. It doesn't matter. So I'm going to choose the first one just because you don't have to. It's up to you. But it's negative 2x plus y equals a negative 13. I'm going to plug in my my y, not the x. I found y. So that's plus 11 equals a negative 13. So I'm going to subtract 11 on both sides here. We can find out what this x is. This gives me a negative 24. I have to divide by a negative 2 on both sides. X gives me 12. So my solution to this equation is going to be 12, 11. So I have one solution here. One solution. There's my x and there's my y. Okay, this one eliminated just nicely. Now, let's analyze this one. I have 3x minus 3y equals 9 and 2x minus 2y equals 6. As I look at this, I can see that nothing can eliminate. Well, this is a perfect time to multiply through by a factor. I see that the 3x and the 2x are both positive. The negative 3y and the negative 2y are both negative. So I'm going to have to multiply by a negative factor in order to make one of these cancel out. So let's see. I'm just going to look at multiplying this first equation by a positive 2, and I'm going to multiply the second equation by a negative 3. The goal is that my x's become 6's, 6x, and a negative 6x, so that they eliminate. That is what I'm trying to do. So I found a factor that I can multiply here that will make both of them eliminate. So let's get started. I'm going to end up with 2 times the quantity of 3x minus 3y equals 9. I'm multiplying all of that by 2. That's why everything's in parentheses here. Then I have a negative 3. That's multiplied by 2x minus 2y equals 6. What this gives me, using distributive property, is 6x minus 6y equals 18. Then I have a negative 6x plus 6y equals a negative 18. Well, let's see what happens here. I am ready to eliminate, so I can see 6x minus 6x. That gives me 0. A negative 6y plus 6y also gives me 0. And 18 minus 18 also gives me 0. So I end up with 0 equals 0. And what that means is I have infinite solutions. Infinite solutions because I ended up with a true statement. 0 does equal 0. So when that happens, it's not no solution. That's very tricky. It's infinite solutions because it's a true statement. All right, for our final one, we're going to again analyze to see if we can eliminate a variable. I have x plus y equals 4, and I have 2x plus 2y equals 2. Nothing can eliminate yet, but if I multiply through by a factor, so that I have opposites to eliminate. Well, I see easily that if I multiply by a 2, I still wouldn't get an elimination because it'd just be everything multiplied by 2. So it needs to be a negative 2 so that those 2's can cancel. All right, let's go ahead and notice this time we don't have to do both equations because this one already at the bottom, equation 2, already has 2x. All right, let's see. Once we use distributive property, we end up with a negative 2x minus 2y equals a negative 8. Remember to multiply everything in the parentheses by that negative 2. Okay? My other equation stays the same because it already has what I need to eliminate a variable. I'm going to go ahead and add and see what we end up with. Well, these eliminate negative 2x plus 2x, a negative 2y plus 2y. Wow. And then we're left with 0 here equals a negative 8 plus 2. That gives me a negative 6. Well, this is not a true statement. So because it is not a true statement, that means there are no solutions for this system. No solution here. For our final one, I want you to look again and see, just to start out, which variable is easier to eliminate. Would it be the x, the y, the 6, or the 4? So let's look at it carefully. I have 3x and 4x. I have y and 4y. And I have 4 and 6. Carefully, as you're looking here, you can see it says which variable. So I'm looking for a variable, not a number. Tricky. So 6 and 4 are not good answers. But the variables are x and y. So which is easier? Well, look at my x's. I've got 3x and 4x. And look at my y's. I have y and 4y. I think it's easier to eliminate the y. And what can I multiply by? It'll be very easy, a negative 4. Once I multiply by a negative 4, I'll end up with a negative 12x minus 4y equals a negative 16. My other equation will stay the same, 4x plus 4y equals 6. And as you can see, right here is where we would be able to eliminate. And that's much easier. And the reason why it's easier is because if I decided to eliminate my x coordinates, I would have to multiply both equations by a number to get 12. And so I'd rather have one step than 2 steps. I sure hope this helped today. As you can see, what we did was solving systems with elimination. So here is a good video for you to take a look at. You also have number of solutions to a system of equations, solving systems graphically, and solving systems with substitution. Thank you so much for watching.